I will discuss what's going on with NVIDIA Blackwell GPU, why TSMC is struggling with manufacturing it, and the impact it will have on the future. NVIDIA has had just their most important earnings call ever. They reported a record high revenue of $30 billion for the quarter, and their data center revenue more than doubled over the past year. But despite this amazing drop from NVIDIA and their earnings beating estimates, NVIDIA stock dropped more than 8%. So what's going on here? Apparently, one of the reasons has to do with the concerns over NVIDIA next generation Blackwell GPUs being delayed, because TSMC is facing issue with being able to manufacture it at high volume. For me, with my chip design background, it was very interesting to understand the technical details of this issue, and many reports indicating that it's coming from the new packaging technology. So I've dug into this. The general trend in the industry is that we are moving towards larger GPUs because AI models are growing exponentially in size, and also the amount of data processed by AI models is increasing. Larger chips can handle more data simultaneously, and this is a huge advantage because with that you can get higher speeds for training and inference. So following this trend, in their new Blackwell GPU, NVIDIA introduced a double die design, and that's also one of the root cause of their problem. This is the high-level floor plan. There are two large GPU dies, which basically contain the core logic, and they are linked by a very fast 10 terabyte per second interconnect bridge. And through this bridge, one die communicates with the other, and every die is surrounded by 4 memories. And to package something as complex as this, they use CoWoS-L packaging technology from TSMC, which stands for Chip on Wafer on Substrate packaging. And in my understanding, this is exactly where the problem is coming from. So if we look at the cross-section of NVIDIA Blackwell GPU, here we have a substrate and an organic interposer soldered on top of it. And then the memory and the logic dies sit on top of this interposer. And these memories and GPU dies are interconnected through tiny bridges, so-called local silicon interconnect. So in this new packaging, we have local silicon interconnect, while in the previous packaging, in the Hopper GPU packaging, we had the kind of global silicon interconnect. This is a general idea. I will explain it in details later in the video. And what's important to understand here that Blackwell GPU is actually an evolution of their previous Hopper GPU, which had a single GPU die talking to 6 memories. And the package was almost half the size of the Blackwell package. Now, the Blackwell GPU is a much larger chip. So they decided to go for CoWoS-L packaging technology, and this one allows to package a bigger design with up to 12 memory dies and at lower cost compared to the CoWoS-S packaging. Now, manufacturing this Blackwell GPU is getting very challenging because you need to assemble all these 10 pieces on top of the interposer and then very precisely align the pins on both sides, on the sides of the logic and also on the memory side. And here we are talking about micron level precision, and there are many thousands of connections in between, so aligning them is not easy. But the trickiest part is to align these two GPU dies, to align the logic, to enable this super fast communication 10 terabyte per second. This is the first challenge, and now NVIDIA is working with TSMC to optimize this assembling process. But there is a second, even bigger challenge: thermals, so-called thermal management. And this topic is addressed in many scientific publications, and it's indeed a challenge. This problem comes from the fact that thermal coefficients of various materials are different. Here we have memory, logic dies, and interposer bridges, all made primarily of silicon, while the interposer and substrate are made of melting compounds, some sort of organic material. And the thing is, all of these pieces has its own thermal coefficient. Silicon, for example, has a much lower coefficient than the organic substrate. So what's happening when GPU is working? It's heating up, and it's getting pretty hot because it can dissipate somewhere in between 700 to 1200 watts TDP, which shows the maximum amount of heat a chip can generate. So it's really hot. These temperature changes cause structural deformations because of the thermal mismatch. What can happen is that the substrate may even bend a little bit and create stress in different directions. An additional issue that different materials expand at different rates, which makes the whole thing somehow dynamic. And this can cause relative die shifts and connection failures between the dies. Actually, NVIDIA doesn't disclose the technical details of this issue. This is my understanding of what's happening with the most powerful GPU. And a part of this problem comes from the fact that Blackwell GPU is a relatively large design. So we need to align many of these components across big area. And now just imagine that all of them expanding at different rates and the contacts are not very well aligned anymore, so it can get really bad very quickly. Let me know what you think in the comments. It wasn't a problem for the Hopper GPU design because it's a smaller design and it was packaged using CoWoS as packaging technology, which places logic and memory on top of a single silicon interposer, which makes it very robust to thermals. But we discussed that the trend is going towards having larger chips, larger GPUs. And if you have a large design, an interesting way to overcome this problem of interconnecting and aligning many dies is to build a single monolithic design. For example, approach which is pursued by Cerebras. They're building a monolithic chip of the size of the wafer. And they have about 80 or so dies, and these dies are connected by wires that just go through the scribe line. And it's manufactured as one single monolithic design. This is a really beautiful piece of engineering. It of course has its also pros and cons. Let me know what you think in the comments. Unfortunately, I happen to know that about 60 to 70% of you watching this video are not subscribed to the channel. If you ever enjoyed my videos, could you please subscribe to the channel? This helps the channel more than you know, because the bigger the channel gets, the bigger the guests that I can interview for you get. Thank you. Now, why NVIDIA didn't go for a single large logic die in case of the Blackwell GPU? This has to do with the complexity and also margins. Basically, you have more usable chips per wafer in case of the smaller designs, so it's more cost effective. But it seems now they have lots of headache with the thermals and also interposer issue. And what's interesting here, I'm pretty sure they've considered that and they've also made many prototypes before. But apparently this issue is more complex. And in my opinion, the dynamics of the real load plays a huge role here, because this thing, it's like impossible to simulate in advance. And on top of that, we know that CoWoS packaging is a relatively new technology. And TSMC...
Pierce, why is my patient getting an MRI?
Nichols, this is Dr. Wolf, our new neuro attending.
Of course, I've heard a lot about you.
I haven't heard about you.
Nichols is our chair of neurosurgery. He performed a procedure on Hannah.
Who hasn't had a single seizure since I operated, so why are you...
but you did turn her into the woman who snubs her kids.
It's expected post-op brain edema. She'll be back to normal in a week.
That's unlikely. She has severe selective emotional detachment.
It wasn't my job to make her a good mother. It was my job to cure her epilepsy, and I succeeded. But by all means, keep wasting your time.
Josh.
Hospital resources.
Oof. Do I ever have to talk to him again?
Yes. Unfortunately, your new job requires working with people who won't always recognize your genius.
CoWoS packaging is a relatively new technology, and TSMC don't have enough capacity for this, so it's getting very complicated. And NVIDIA has already realized that. The original plan was to manufacture 1 million GPUs per quarter, but this is not happening. And NVIDIA is trying to compensate for this ongoing situation in two ways. First of all, it's expanding its Hopper GPU shipment and also introducing a new B200A GPU, which is a lower-end version of B200. And this one, guess what? Using more mature CoWoS as packaging technology. So it's again a single die design surrounded by 4 memory dies sitting on top of a silicon interposer. And we know that TSMC achieved high yields with CoWoS as packaging, and there appear to be no thermal or manufacturing issues. And while I was in the process of recording this video, NVIDIA reported that they solved the Blackwell yield issue with a new lithography photomask. As you may know, photomask defines the pattern of circuits which are printed on the wafer. And this is likely to address the issue that has to do with the N4P manufacturing process, or maybe addressing the interface between the chip and the package. In my opinion, it's unlikely that you can solve thermal problems with just updating one single photomask. Let me know what you think in the comments, because I think that NVIDIA with TSMC experts will eventually figure it out. And despite this situation, I remain optimistic about the long-term prospects of NVIDIA, because
beyond a genius.
at the moment, they have more than 90% share of AI data center market. And according to McKinsey, computing demand for AI workloads will increase more than 100 times over the next 5 years, because more and more people and businesses adopting AI in their work. And if you want to take advantage of AI in your work or research, you must check out Poe. Through Poe, you can access models like GPT-4o, Claude 3.5, Llama 3.1, and Gemini all in one place. And this goes beyond just text bots. Poe lets you create images with the state-of-the-art image generators like Ideogram, DALL-E 3, Flux Pro, and more. And this is a huge cost saver, because you don't need to juggle multiple subscriptions. You can get access to all the best AI products in one place for the same cost as ChatGPT Pro or Claude Pro. I've been using Poe for a while now, mostly for writing and research. And I love having access to multiple models because each of them has its own strength. For example, when I'm researching a topic, I can query Claude 3.5 and compare its response to the GPT-4o or Mistral large model with one click, and then pick the best response from them all. Beyond that, Poe offers a huge variety of bots that specialize in a particular task. So if you're interested in a specific topic such as programming, storytelling, or anything else, you can find a bot that is just right for you. Check out the Poe platform for free through the link below, and thank you for supporting the channel. Now watch this video where I explain what is next for AI and AI chips in general, or this video where I explain the new Huawei AI chip and if they are closing the gap or not. And I will see you in the next video. Ciao.
How much cash do you need? Set up direct deposit and learn how to get up to $500 before payday.
There are two interesting updates on the AI chip market. First of all, everyone is talking about the recent progress in Chinese AI chip development, with the recent photonic chip and their new AI GPUs. And as always, with my background in chip design, I'm interested purely in the technological side of this story. So we know that before the US restrictions, NVIDIA's share of the Chinese AI chip market was over 90%. But now many Chinese companies are working on developing AI chips locally. And one of the biggest players is Huawei, who is about to start shipping their new AI chips. Till now, the most competitive AI GPU designed in China was Huawei's Ascend 910B chip. Based on the official specs, it falls between NVIDIA A100 and H20 GPU. It's actually more powerful than NVIDIA's H20 GPU, which is the best NVIDIA chip on Chinese market at the moment, and closer to the performance of NVIDIA's A100 GPU. But the thing is, we know how much they've really struggled with chip defects. Based on the media reports from the Chinese media that I found, they're facing really bad yields. They write that 4 out of 5 chips have defects, and those are really terrible numbers. In chip manufacturing, yield refers to the proportion of the functional chips compared to the total number of the chips on the wafer. And we love high yields because high yield indicates that there is a high number of defect-free and fully functional chips, while low yield indicates that many chips are defective, like in case of Huawei chips manufactured by SMIC. Technique. Now, Huawei is about to start shipping their new 910C GPUs, and the demand for it on the Chinese market is huge. But I assume that with this new redesign, they will be first targeting to fix the yield problem, and only then focusing on boosting the performance. But improving manufacturing yield is honestly a rocket science. It's a very complex matter. Of course, a huge part of the Huawei's problems with the GPU comes from SMIC struggling with their 7nm manufacturing process, because it's a huge challenge to manufacture 7nm chips without EUV machines. So SMIC is trying to push DUV machines to the limit, and as a workaround, they're using so-called multi-patterning technique. And this involves several layers of masking and several wafer exposures to print just a single transistor feature. And that's quite a hassle. And of course, it's error-prone. I've explained how it works in